So if our clocks are running differently on the top and the bottom, well, how can that be if our G values are the same? And if gravity's reason for speeding up and slowing down clocks is an entirely local effect, then the local effect that happened at the bottom would also be identical to the effect that happens on the top. So all of these facts within the confines of Einstein's relativity cannot possibly be reconciled. A final thing which will throw a monkey wrench in the critics' view of this theory is, let's say that my planet Uranus example is a little sloppy and is a little incorrect, and we don't get the full 7,000 special relativistic effect from the perspective of the satellite. The key here is, again, we are not in the center of the Earth, which would be the center of this rotating frame, which we could also look at here, okay? The clocks are actually compared from the outside here at 11,000 miles to the surface of the Earth, which I said is about 25% of the way out from center. Because of that, when these satellites are in orbit, you have constant distance changes between the satellite and any receiver clock, any ground control station clock, constant distance change. Unlike the situation if we were dead center. If we were dead center, we would have rotation, but at least the distance would be the same throughout that rotation. In this particular case, the Earth is revolving at its own speed, and these are orbiting at an entirely different speed, and they're off of the center. So what that means is that at various times of the day, you are changing your distance between the satellite and any clock that the satellite is communicating with, right? Anytime you have a distance change over time between two objects, you have relative velocity. And even though it would be a smaller example than my planet Uranus example, it doesn't matter because the relative velocity cannot possibly be compensated for in both directions, because Einstein says if you have two things in a state of relative velocity, each will see the other's clock slow down at the same time. And we've already proven that there's no possible way, there's no possible adjustment that you can make that will make both clocks happy and be synced in both directions when we have that effect. So, like it or not, we either have a lot of relative velocity or we have less relative velocity, but we do in fact have relative velocity. And in either case, it would be enough to be a significant effect on the measuring of GPS receivers for sure. So, if all of this is true, then what that does is that actually puts that aspect of special relativity in jeopardy. And by doing that, it calls into question Galileo's principle. Now, Galileo didn't have a lot to work with way back when. He didn't have beams of light, he didn't have lasers, he didn't have detection devices, he didn't have particle accelerators. He basically had a boat and some butterflies, right? But with that boat and the butterflies and the dropping objects and the drops, with all of the physics that he was familiar with, he did not see any difference whatsoever between behavior inside of a boat moving at constant velocity and a boat that was docked, okay? But in this particular case, when we use GPS and the very, very sensitive atomic clocks, and we compare that to what Einstein says about using light signals in a way that preserves Galileo's principle of relativity, it just cannot possibly be. And again, why is this important to us? Because we really want to get to the fundamental root of what it is that's causing these time changes, both in gravity and both in velocity. The interesting thing here is if we can kind of disregard that part of Einstein and Galileo's relativity, then we might be able to say that an object in motion that experiences a time dilation that an object not in motion doesn't experience, we now have some sort of absolute nature and an absolute explanation to this time dilation. This actually opens up a lot of doors to investigating the nature of time. So again, going back to my temperature example and my what is color example, we find some sort of fundamental explanation for these things that we perceive in the universe. Time is something that we perceive. We watch clocks tick. Sometimes time drags, sometimes time flies by. But regardless of all that, is there some sort of fundamental explanation or mechanism or behavior that's responsible for all of that? If we can disregard that part of Einstein's special relativity, I believe that that actually opens up the door to be able to look at that in a different way. Because one of the things that could possibly be is that the act of acceleration itself or gravity or constant velocity, any one of those three things that has an effect on the way that the clock ticks in that particular environment, all three of those things could be putting some sort of stress on the fundamental behaviors of those objects that are in motion. So whether you're talking about a wind-up clock with a spring in it, whether you're talking about an atomic clock, whether you're talking about an individual who has all these physiological things going on with heart beating and pulse and that sort of thing, when that system moves, time, the entirety of time slows down for that individual and for that system. And it is quite possible that all the fundamental behaviors that are responsible for what we outwardly see as motion and other things, those fundamental behaviors are actually acted upon by gravity, acceleration, or constant velocity, and they place a stress on that local environment and actually have an effect on the rate at which those fundamental behaviors can occur. And it is possible that constant velocity, along with these other two examples, something is happening there where if those fundamental behaviors are occurring at a certain rate, it's interfering with that very same rate as a consequence of that constant velocity itself. So this brings up a very important question, because what we can ask at this point is, do all the fundamental behaviors in the universe, the big ones like watching the second hand click on the clock, all the way down to subatomic behaviors that are very fundamental that decide other things, do all the behaviors in the universe exist in time, meaning that time is still something mysterious in the background that we don't know what's going on, or are all those behaviors actually time themselves? And the expression of all those behaviors actually are the expression of time, and by moving these objects, accelerating these objects, and taking them in and out of gravity, we can actually affect the rate at which these fundamental behaviors occur. And since the act of these fundamental behaviors is something we perceive as time, then that would be a very simple explanation for why all of this is tweaked up or down. Right? So obviously more is going to be done. There's a huge interest in time. There's organizations who study this and study nothing but this. There's a lot of experts out there who have a great interest in this in one form or another. But I will leave you with one thing, that if you consider the possibility that the actual behaviors themselves are an expression of time and that they don't exist in time, then that simple possibility is not and cannot be consistent with Einstein's mutual symmetrical time dilation slowdown. So, hope you enjoyed it. My website is www.sciencewithoutfiction.com.